trying to see if the given improper integral x divided by x to the fourth plus 16 is convergent or divergent when the limits are from negative infinity to 0. Notice immediately that the negative infinity is the troublesome lower limit here. So what we have to do, first of all, we have to use the U substitution, right? Because we can't solve it without that. So let U equal to x squared over 4. Now, how do I know x squared over 4? Because notice that if we square the x squared divided by 4, we will get x to the fourth divided by 16. And 16 is the same number as this 16. Right? So as you will see, this will be a very good substitution. So the du is going to be 1/2 x dx, right? Using the power rule, you will know that the derivative is 1/2 x dx. Now, what is x to the fourth equal to? X to the fourth is going to be 4u squared, right? So 16u squared. And so now we're ready to substitute, but we have to solve for dx as well, right? So the dx, so let's actually do x dx. X dx is going to be 2 du, right? Multiplying both sides by 2 solves for x dx product is 2 du, right? So now, but there's one more thing. We have to change the limits of integration because we introduced a new variable, right? So u as a function of x. So if you plug in negative infinity divided by 4, negative infinity squared is positive infinity. Positive infinity divided by 4 is still positive infinity, right? So it's going to be positive infinity in the bottom. And then now plugging in u here is going to be u squared over 4 is 0, right? So now let's put what we have. So x is what? X dx is 2 du, right? So it's going to be 2 on the top. And then here we're going to have what? X to the fourth plus 16 is 16u squared plus 16, right? And then the du, of course. Now, notice that there's a slight discrepancy here. We cannot have the number greater in the lower limit, right? Because, well, this is not a number, but this is infinity. Infinity is definitely greater than 0. We have to have infinity on the top and 0 on the bottom. So to do that, we just negate the integral and change these limits, replace them, right? Basically switch them, right? So it's going to be infinity on the top now and 0 here. So now let's also put a 2 here because the 2 is the constant. And also let's put 16 outside as well because 16 can be factored out, right? So it's going to be 1 over 1 plus u squared du. So notice that this looks like an arctan derivative, and which is good, but you're still not done, because first of all, let's make this 1/8, negative 1/8 precisely. And also we have to introduce the limit now because we have a troublesome place at the infinity here, right? If you plug in infinity, you will have 1 over infinity, and that's not allowed, right? You don't know what the value is, right? So you have to bring the limit, and as r approaches infinity, obviously, so you're going to replace the infinity with the r, so it's going to be 1 over 1 plus u squared du. So now it's going to be arctangent. You have to keep the limit as r approaches infinity, so the arctangent of u from 0 to r. So now let's see, this is going to give us negative 1/8. The limit as r approaches infinity, arctan of r minus arctan of 0. So this is going to give us negative 1/8. Now, so now we can plug in the infinity, arctan of infinity minus arctan of 0. Now here's an important thing to consider. How would you know which angle measures to choose here? Notice that you can only have y is equal to arctan of x if and only if tangent of y is equal to x and y falls within the range, well, not within, but between negative pi over 2 and pi over 2. why are the endpoints not included is because the tangent of negative pi over 2 or tangent of pi over 2 is undefined. Okay, there's no value for pi over 2 and negative pi over 2. You might think, well, isn't that infinity or negative? Yes, but infinity is not a number, right? So that's why we don't include these values, the endpoints. But the value must be between these two. So now we can use this constraint to actually find the angle measures that we're looking for. So we're going to have, what is going to be the arctangent of infinity? We know that precisely, I just said that the tangent of pi over 2 is infinity, right? So we know that the angle measure whose tangent is infinity is precisely pi over 2. Now what's going to be the arctangent of 0? We know that the tangent of 0 is 0, right? So the angle measure whose tangent is 0 is 0. Okay, so it's going to be negative pi over 16. You might say, but wait a second, why does the improper integral converge to a negative value? Well, it happens when most of the area is below the x-axis, right? When the area is below the x-axis, let's say the line falls below the x-axis, the curve, right? The curve represented by this function here, x over x to the 4th plus 16. If most of the area is underneath the x-axis, you will have a negative result. The area will be negative, right? So in this case, the convergent improper integral value is negative because most of the area falls under the x-axis. Okay, so don't be discouraged if you get a negative result. It doesn't mean it's wrong. So I hope this was a lot of fun. Thanks for watching and see you in the next video.